Hello, everyone. In this lesson, we're going to build on our knowledge of defining our own functions by talking about the idea of overloading functions. So, the overloading concept just refers to when you give two or more functions the same name. The best way to understand this is to start with an example like we have here. Both functions are designed to find the average of their inputs. So, the first one will take two ints, and the second one takes in three integer inputs, and they both give you back the average with decimal precision. So this it qualifies as an example of overloading because we've used the exact same function name for these two functions. They're both called findAVG, and what makes them distinct is that they have different parameter lists. The first one expects two ints, and the second function expects three ints. So that's really at the heart of overloading. You'll use the same function name, but keep the parameter list different in some way, either different numbers of parameters or different types of parameters. So the main reason to use overloading is that it improves the readability of your code. Rather than having to use names like find average of two numbers and find average of three numbers, we could simply reuse that name findAVG that we saw in those examples. Now, when you're overloading, each function must have its own declaration and definition. So those two definitions we saw for findAVG would each have their own declaration that would go with it. And again, at the heart of overloading is that you must have different numbers of formal parameters, or some parameters have to have different types. You can't overload by keeping the parameter list identical and just changing the return type of the function. Now the compiler decides which function it's going to use just based on the number of arguments that are in the function call. So if we did findAVG 10, 20, it would use the first definition we saw in that last example, and if we did findAVG 10, 20, 30, it would use the second one that was expecting three ints. Now let's go through some examples based on this declaration we have here. The function has a return type of int, it's called mystery, and the parameter list consists of an int followed by a double. All of these will be examples of correctly overloading. They all use the same mystery, and they would all qualify for overloading due to something about the parameter list in each one. So in our first example, we can see that the first parameter has been changed from an int to a char, and again, the type of the first parameter is different, so that will successfully overload the mystery function. In the next example, we have a double followed by an int, which is different than the original order of an int followed by a double. So in this case, each parameter has a different type. And again, that will successfully overload the original function. Our third example here, we've changed the type of the second parameter from a double to an int. So again, that will successfully overload the original function because our second parameter has a different type. Next up, if we change the parameter list to have two parameters down to one parameter, that will definitely qualify as overloading. A different number of parameters will definitely allow you to overload a function. The return type being different really has nothing to do with it. It's the fact that there is now one parameter instead of two. In our final example, the three parameter list is distinct from the two parameter list in the original function. So again, a different number of parameters will allow you to overload that mystery function. Now let's look at some non-examples based on that same declaration. So keep in mind the parameter list is an int followed by a double. And in this first example, we have, again, an int followed by a double. So simply changing the return type to double will not allow us to overload that mystery function. Again, we have the same number of parameters, and each parameter is of the same type, an int followed by a double. So this first one will not work for overloading. We have the same issue in this second example. Again, we have an int followed by a double. It's the same order of the original as the int followed by a double. And just changing x and y to num1 and num2 is not going to trick the compiler into thinking you're overloading here. So again, same number of parameters, same types of parameters. That one will not successfully overload the mystery function. So to recap, what matters most for overloading a given function name is that the number of parameters must be different, or at least one parameter has to have a different type. Again, you really want to focus on the parameter list when you're analyzing overloaded functions. Now, another idea is what's called automatic type converting in C++. So generally speaking, C++ is going to treat an int as a double whenever you plug in a value of type int where it expects a double. This has happened so often that you probably haven't even thought about it. For example, in the predefined functions that do mathematical calculations like the square root and the pow function, you can pass in 25 where it expects a double, and it's going to treat 25 as the double value 25.0. And another example would be, say, the pow function. You could plug in 2 where it expects a double, and it would treat the 2 as a 2.0. So most of the time, where a function expects a double, you can safely plug in a value of type int, and that int will automatically be promoted up to a double. However, when you're overloading, you might lose this functionality if you're not careful. So if you provide a function with the same name and change parameters of type double to type int when you're overloading, you might lose the functionality of this automatic converting. So let's say in this example here, that's pretty far-fetched. You had an MPG function for calculating gas mileage. Would take in miles and gallons both as doubles. And then you had another function for the measure of perfect goals, where you took in goals and misses as int values. And if you did the function call mpg, say 200, 7, and you intended to find your gas mileage for a 200-mile trip where you use 7 gallons of gas, it would unfortunately go to the second function definition that has the two int parameters. Now, what you're realizing here is these two functions really have nothing to do with each other, so it's not really an example of a good use of overloading a function name. So you're unlikely to bump into this issue. It's just something to be aware of. Mainly, I would suggest just don't use the same name for two totally unrelated functions like you have here in this, like I said, pretty far-fetched example. It's just something that you want to be aware of. Now, to end with, I'd like you to pause this video and practice figuring out which one of these would correctly overload the double calc something function that's declared up here. So notice double calc something expects an int followed by a char followed by a double. And I'd like you to pause and determine which one of these would correctly overload that calc something function. So hopefully you took my advice and paused the video, and the ones that would correctly overload it are 1, 2, and 4. So in each of those examples, either the number of parameters or the types of the parameters are distinct in some way compared to the original. So if you look at number 1, the int parameter that came first is now a double parameter, and even though the other two parameters have the same type, that is definitely a distinct parameter list compared to the original. In number 2, the parameter list is now only consisting of 2 parameters as opposed to 3, so that will absolutely overload the original. And in number 4, we've changed the type of the second and third parameters. The char is now an int, and the double is now an int. So again, that will successfully overload the original. The ones that would not work are 3 and 4. In number 3, you'll notice the parameter list is completely identical in both its type, kind of parameter for parameter. It's an int followed by a char followed by a double. So simply changing the return type from double to int is not going to work. And in number 5, you're not going to trick the compiler by just changing the names of the parameters at all. If we take a, b, and c and make them x, y, and z, the compiler is going to treat these as two totally identical functions. It knows no better than just an int followed by a char followed by a double. So make sure you use the notes you took in this video as you're working through the problem set. You'll get some practice analyzing overloaded functions, and then get some experience writing a couple examples before you start to code with this.